So hello everyone, today in this tutorial I want to show you how do we map deforestation vulnerability in Brazil. And here is the result you see in the Earth Engine app, and we will use Google Earth Engine for this task. So as you can see, we will have the vulnerability mapped by looking into how the topography and road access are different area in the Brazil. And from there we can look at the area that are closer to urban and rural are much more vulnerable to deforestation, are easily logged compared to some more remote and intact regions and forests in the area. So in order to show you how do we do all this, I really want to show you what the source data we are looking into, so you can also have some ideas how do we look into different interesting data set that we could try to develop our application. So first of all, it's a very useful data set from the Hansen global forest change. So it basically detect the changes of forest, like it's a global data set for different time stamps. So we can look into the year that the forest is lost. And this is the first data set we will use to compare our result with the forest change with historical record and detection. And second data set is like a COIA data set that we are using for our model today, and this is the global friction surveys from 2019. So this is the data set that is utilizing topographic conditions as well as different road from the OSM, for example, to look at how easy is the pixel to be accessed by car or by walking. And I find this dataset pretty nice. I recently found it out, and I see that might be quite relevant for the deforestation application. That's why I'm showing you this. And with the band, we can see they have the frictional band that is referred to the land-based travel speed, and we can also look in the walking only band, but I guess this is not as relevant for the deforestation application. Thirdly, I want to introduce you this nice data set from the GeoBoundaries global database. So this is a very useful data set for all kind of applications, and it is showing you basically administrative boundary for different countries in the world. And it's a global data set. They have different admin level, and this is hosted by the awesome GE community data node, which also have all sorts of very amazing data set that we could use for different kind of remote sensing and geospatial application here. So yeah, let's go to our tutorial with the Google Earth Engine code today. So first of all, for the reason to show you everything more smoothly, I'm only focused on a smaller area here defined by my geometry. But you could also want it for the whole country, for the whole Brazil here. So apart from the definition of geometry, you could also uncomment this. Now I'm not using it now, but what we basically do is we imported the feature collection from the GeoBoundary dataset, and here we could choose admin level. We use admin1 for the whole country, and then we have the variable admin1, and this includes all the countries, right? And in order to get Brazil, we just need to use the filter function with filtering the properties, which is called shape group, equal to the ISO fee code of Brazil, which is BRA. So we have here. I mean, you can also just change the code for different countries. But yeah, we are getting Brazil here, and that will be assigned to geometry variable, and we could do the whole analysis for the whole Brazil. And to just some basic setup, we also will center our map to the geometry, which is the rectangular area here, and we will set like options. As this is deforestation application, I find it really nice to looking into the satellite based map as well with some labels. So I will use hybrid here. And for our COIA dataset to be imported, so we are imported this EE image with this dataset of friction surveys from 2019. and we will select the friction band. And as this is like a global data set, we have to click to the focus area that we are interested in. So we will click geometry here. And let me show you, if you like have an image like this and you want to put it in the map, how do we do it? So first of all, we have to have our visualization parameters. Is a dictionary. Inside I always put like you have minimum, you have maximum value that you want to show, and the plateau. So I guess this is something you can just pay a 1 and to see how it changed the visuals there. And for the plateau we are using red to blue gradient. So this is what you can see here from just a nice visual to show how the frictional surface layer look like. So yeah, but first let's look into this frictional surface layer. So if we compare to the satellite base map, we can also already see some nice representation of some logging road here inside the forest. And also road access itself is also quite very relevant to the vehicle for forest logging. So here, so you can see then with the red area mean that the area is very accessible and is more vulnerable to deforestation compared to the area here that are more intact, so to say. So we are actually visualizing our layer here. So when we want to visualize our layer, we use map add layer, and we put into the image here. It have to be an image and not a collection. So then we put our visual parameter, which is the dictionary here. Then we have our title. So we could see here with our title, and this is by default showing or not. So by default, the layer will always show, but if I say false here and I run it, the layer will actually be uncaked. So then we can actually add further parameter, for example opacity, to make it a bit more transparent, but I'm not doing it here. Then the second layer I want to show is the forest loss layer from Hansen. And we do the same of just importing a UV image here. And for select, we always select the band. So from the documentation, we know what band the dataset has and what it represents. And so we choose the loss layer band here, which represents in which year is the forest detected to be deforested. We set up our parameter again. So from 0, which is deforest in 2000 until 2023, then we can actually just show the historical record of the deforestation. And we use the pattern white to red here, just to show have some nice visual. And here we also want to put the forest loss layer into a map now. We do map add layer, and we have our loss image, and we click geometry as we really want to only look into the area we are focused in. And this is another function called update mask. So what it actually do, it only show you or visualize the area with a certain condition. So for example, for tree loss before 2019, then we have also included 2019. Then we have the tree loss that with the detection of the deforestation before 2020. So then we have 2019 and then 2018, and also beforehand with the historical record of forest loss that are put in this layer here. So then we also have tree loss after 2019. So I just put like greater than 2018. So then we basically have the loss area for 2 different time period, and I do so because I want to just make the visual nicer. So I put different parameter of opacity here to make it transparent in different level. So if we look at our tree loss layer here, let's disable this to make it more clear. We can see that we have our tree loss before 2019 here that are shown very nicely according to also associated with the road access I show you. and then after 2019. So you see it's basically like the edges of the old deforestation area. So you see basically it's like kind of like expansion. So you can see actually very nicely here. Yeah. And now we can compare our, this is mostly for like some visual inspection to see how logging is developed in this area. However, now we have to go to, our model, right? How do we understand deforestation vulnerability using the dataset I just showed you? So first of all, I will develop a cost model in this, and this is how I will show you today. And how does it work? So basically we have to have a source of deforestation. And here I define it as urban area, because I believe that with like villages and area that actually their population and their good infrastructure, they are mainly like the source of deforestation, because that's what the deforestation is done by the people there. So yeah, let's put our urban area here as the source for our cost model. So I'm also using Landscan global dataset here. So it's basically showing you like some urban area and population count. And I have experimented different dataset here as the urban area, including the Israel cover with the urban land cover. But I found this Landscan dataset, quite accurate also regarding area that may be inside the forest, but there's still some small amount of residents are living there, like small villages and so on. And that's why I'm using this Landscan dataset to define an area that are, let's say that are occupied by residents. And here, because this is a time series dataset, and when we have a time series dataset, also we have an image collection, not an image, as we have multiple of them, and we have to sort them with the time start with false. And what it means is I want to have the latest image right at the beginning, and just basically reverse sorting. And then we have the first image. So what this tool now telling us is we want to get the latest image. So we don't want to get like the older data, we're going to get the latest data. And just to do some filtering, I try to get pixel with population that more than 10 people. And here it's just basically, it is more like a threshold to check in, we want to exclude some super small noise, but more want to look into like some kind of village that are having certain population that is maybe more risky for deforestation. And we clip it to our rectangle here. Then we have our urban area. And to calculate our cost model, let me quickly tell you how this works. So for the cost model, we are using cumulative cost, which is basically from the source area, it will find out the least cost path. So, and then to calculate all the costs that included in this least cost path. So for example, we have our urban area at the source and we have forest here. And in order to, for this area to be deforested, let's say the nearest urban area is here. I have to go all the way, maybe like a straight line, maybe a least cost path, but maybe it's not. However, then we have to sum up all the costs for the pixel by pixel. And for sure, then the cost model at the end will base really on the distance between the pixel and the source pixel. However, it will also base on other parameters, as we have our global friction, and the global friction is also depending on parameters such as going up slope and different kind of land use and road access and so on. So then it's not really just rely on the distance to the source, but also other parameters taking into account as well. And for this accumulation cost function, we have to put our cost here, and our cost image is the global friction surface. So I put our travel speed here, that's the variable name, and I calculate the cumulative cost function. And we have our source, which is the urban area that are occupied by human. and here we have a maximum distance here. So I guess depend on how large is the area you're looking into. If you're looking into like very huge area, you might need a much more larger value here. However, it will also be a bit slower when you run it as well. So I guess you have to try to balance and choose the value here. And as we are looking into a smaller area, I can just put 500,000 here. And here is the geodetic distance. If you put true, it's a bit more accurate, as it's like calculating, you know, the 3D or the projection of the Earth. However, it's a bit slower. So yeah, that's up to you. And we clip the geometry here as well for our layers. And then we have our cost model. And with the same visual parameters I show you how to set up, we do exactly the same. We set up like a library to show the cost, and we try to visualize it here. And actually one thing I also want to show you is now let's look at our cost model. Yeah, one important thing here, as we know that actually when we calculate the cost model, it doesn't only cover forest area but also cover urban area that cannot be deforested anyway, as well as other surveys, like say agricultural fields and so on. So in order to mask them out, I use the canopy height data from this global canopy height from 2020, so which is also a nice data set. And I try to get the canopy height greater than 10 meters here. So then we have only trees that are higher than 10 meters in order to be used for this cost model. And with the same, I visualize this layer as well, but also for the cost surveys layer, I use it for the mask to mask out already deforested area. For example, here, then it's not very relevant for deforestation. And also, by the way, I also use the log, as when we calculate the cumulative cost, it's not linear most of the time. So you have very far, not completely intact area that are like super high cost, as well as on the other hand, this area, let's say coastal city, is like super low cost. So it's not really linear. So to stretch the visual out and make it nicer in the visuals, I use log to transform like the color. So then we have a cost model at the end with the add layer. So here, that's how you see how the final result look like. And then so we basically have area that are close to the logging world and close to the human populated area that with higher cost, as well as it's like spread out how depend on how the road develop and building. We also see the kind of more risky area along the road as well. And we can also see actually quite nicely, not only compared to the tree loss from the past, but also if we look at our satellite base layer, we can also see how it associated with the deforestation edge, or we can see also visually. And we might actually see the area that might be actually deforested in the future that are more prone to deforestation compared to the other area. So yeah, this is what I want to show you today. I'm happy that you are with me, and yeah, I'm happy to see you soon. Bye bye.